In this video, I'm going to go over how to divide radicals, and primarily this is going to focus on how do we rationalize denominators. So you can label this dividing radicals. And by the end, you're going to be able to explain why do we use conjugates to rationalize the denominator. So what does it mean to rationalize the denominator? So rationalizing means that we're getting rid of a radical, which is an irrational number. We're getting rid of the radical in the denominator. We don't want to see radicals in the denominator, so we do this process called rationalizing. So let's see this with an example. Example 1. So we have 4 divided by the square root of 6. So if I want to rationalize the denominator, what I'm going to do is I want to get rid of the denominator of the square root of 6. I want to get rid of that down there. So what we do to rationalize the denominator, we multiply by the denominator divided by itself. So the denominator is the square root of 6. And so I'm going to put that on the top and on the bottom. So I'm dividing by the square root of 6 divided by the square root of 6. So, and just so that you remember, any number, so let's say like 2 divided by 2, any number divided by itself, remember, is 1. The same thing is true with radicals. The square root of 6 divided by the square root of 6 is 1, because any number divided by itself is 1. So this is not changing the problem. You're allowed to multiply by 1. So here I'm multiplying, so I'm just going to multiply 4 times the square root of 6. Notice the 4 is not inside a radical, so it's going to stay outside. So I'm going to write 4 square root of 6, and then divided by 6 times 6 is 36. So this is over 36. Now, we can reduce this. We know the square root of 36. The square root of 36 is 6. So this is 4 square root of 6 over 6. And the last thing we could do is just notice we can simplify this. 4 divided by 6, that's going to reduce. Those are both divisible by 2. So if I divide that by 2 and that by 2, this is going to be 2 root 6 over 3. Example 2. So I have a square root in the denominator. So I want to get rid of the square root that's down there. So what we're going to do is we're going to multiply by the square root divided by itself. So the square root of 15 divided by the square root of 15. Because remember, any number divided by itself is 1. So in this case, I'm using the square root of 15 because that's going to help me get rid of the 15 in the denominator. So when we do this, we have 4 outside the radical. So I'm going to put 4. And then the 3 and the 15 are both inside. So this will be times 3 times 15. And I'll just show that one so you can see the multiplication. And this is divided by 15 times 15. And again, I'll just show this one so you can see the multiplication all the way through. 3 times 15, so this is going to be 4 times the square root of 45. Divided by the square root of 225. We can simplify some of this. So let's start with the square root of 45. So we can split up 45 using your perfect squares. So 45 is going to be 9 times 5. And so this is going to be 4 times the square root of 9 times 5. Divided by, well, the square root of 225, we know that. That's 15. That's one of the perfect squares. And then now we're just reducing this radical up here. So the square root of 9 is 3. So that's going to come outside the radical. Whoops, sorry. So it's going to be 4 times 3 square root of 5 over 15. 4 times 3 is 12. Square root of 5 over 15. And then again, we can divide 12 by 15. So those are both divisible by 3. Remember, you can only simplify the numbers that are out front of the radical. So here we get 4 square root of 5 over 5. So those are both divisible by 3. So notice we didn't change what was in the radical. When we simplified at the very end here, we just left it alone. So here's one that I want you to try on your own. So -2 times the square root of 3 divided by the square root of 7. So give that one a try. Pause the video, try it, and when you unpause it, I'll have a solution here for you. So hopefully you gave example 3 a try. So what you do is you multiply by the square root of 7 divided by the square root of 7. And then you get -2 square root of 21 divided by the square root of 49, because the -2 is the only number on the outside of that radical. And then the square root of 49, we know that is 7. So this is -2 square root of 21 divided by 7, and then this can't be simplified, so this would be your final answer. So example 4. So here we have 8 divided by 4 minus the square root of 14. This is where you're going to need to use the conjugate. So if you have two things in the denominator, you need to use the conjugate. So the conjugate of the denominator, so the conjugate of 4 minus the square root of 14 is 4 plus the square root of 14. So instead of multiplying by just the radical, we're going to multiply by the conjugate divided by itself. So we would do this one like this. So 8 divided by 4 minus the square root of 14. And we're going to multiply by the conjugate divided by itself. So I would write 4 plus the square root of 14 divided by 4 plus the square root of 14. And then this is just multiplying radicals, which we looked at that previously. So if you multiply, we're going to just distribute this 8. 8 times 4, so in the numerator, I'm going to have 8 times 4, which is 32, and then 8 times the square root of 14. So remember, 8's not inside a radical, so it's going to stay outside, and I'm going to write square root of 14. And then in the bottom, this is just you're multiplying two binomials here. So remember, we're going to use FOIL for this. So for FOIL, first outer, so 4 times 4, which is 16. Inner, so 4 times the square root of 14. Well, this 4 is on the outside, so it's going to stay outside. So I'm going to put plus 4 square root of 14. And then the inside, so now I'm going to do negative square root of 14 times 4. So this is like saying -1. You can think of this as -1. So -1 times 4 is -4 square root of 14. So that 4 was on the outside, and so was the negative. So I kept them both outside when I multiplied through. And then -1 square root of 14 times positive square root of 14 is just going to be negative square root of 14 times 14, like that. So this is what you get when you do all your multiplication. Now you need to simplify. So the numerator can't simplify, so we'll leave this as 32 plus 8 square root of 14. This is fine the way it is for now. But on the bottom, in the denominator, we can simplify some of this. Notice I have 16. And then the plus 4 square root of 14 and the minus 4 square root of 14, those are both 0. So those equal 0. So those are no longer there. And then I have minus the square root of 14 times 14. Well, 14 times 14 is 196. And we know the square root of 196. This is a perfect square. It's 14. So this is 32 plus 8 square root of 14 divided by 16 minus 14. So 16 minus 14 is 2. So this would be 32 plus 8 square root of 14, all divided by 2. And I'm going to split this up so we can see this as 32 divided by 2 plus 8 square root of 14 divided by 2. So I'm just splitting this up into two separate fractions. So the first fraction is 32 divided by 2, and the second fraction is 8 square root of 14 divided by 2. So 32 divided by 2 is 16. 8 divided by 2 is 4, and then I have my square root of 14 left. Remember, you can't divide 14 by 2 because the 2 is not inside a radical. So we're just going to leave it like this. So 16 plus 4 square root of 14 is your answer for this one. So example 5. So we have the square root of 5 divided by 3 plus the square root of 5. So remember, when you have a binomial, so in other words, when you have two things in the bottom separated by addition, you're going to need to multiply by the conjugate, so the denominator. So the conjugate of 3 plus square root of 5 is 3 minus the square root of 5. So I'm going to multiply by the conjugate divided by itself. So I multiply by the conjugate of the denominator. So this would be 3 minus the square root of 5 over 3 minus the square root of 5. And so now in the top I have the square root of 5 times 3 minus the square root of 5. And in the bottom I have 3 plus the square root of 5 times 3 minus the square root of 5. And now to simplify, I'm just going to multiply all this out. So there's quite a bit of multiplying going on, even though we're just doing rationalizing the denominator. There's quite a bit of multiplication that occurs here. So square root of 5 times 3. The 3 is outside the square root, so I'm going to write 3 square root of 5. And now square root of 5 times negative square root of 5. Notice the negative sign is here, so I'm going to write minus, and then the square root of 5 times 5, well, 5 times 5 is just 25. So I multiplied my 5s because those were both underneath the radical. Divided by, in the denominator, do FOIL. So in the denominator, I'm going to FOIL. So first outer, so I'm going to do 3 times 3 is 9. 3 times negative, remember this is like a negative 1 here. So there's a negative sign in front. So 3 times negative 1, so I'm going to write plus 3 times negative 1, just so that you can see I'm multiplying the numbers in front, and then my radical is the square root of 5. Then I'm going to do the same thing here. So I have square root of 5 times 3. Well, that 3 is positive. Both of those are positive, so I know my answer here is going to be positive. This will be plus 3 square root of 5. And then now I'm going to do positive square root of 5 times negative square root of 5. So now it's just a game of simplifying. So I have 3 square root of 5 minus the square root of 25. This is a perfect square, so this is going to come out. The square root of 25 is 5. And then in the bottom, I'm going to have 9. 3 times negative 1 is negative 3, so negative 3 square root of 5 plus 3 square root of 5. And then now square root of 5 times negative square root of 5. Remember, if you multiply numbers out front, this is positive 1, and this would be a negative 1. So positive 1 times negative 1 is negative 1. Square root of 5 times 5, so my insides, is 25. So when I multiply those two 5s together, I get 25. And now simplify this a little bit further. So 3 square root of 5 minus 5, all divided by 9. And then for my next part, negative 3 square root of 5 plus 3 square root of 5, those equal 0. So they cancel out. And I'm left with negative 1 times the square root of 25. And then next, so I have negative 1 times the square root of 25. The square root of 25 is 5. So I'm going to write So square root of 25 is 5, and I'll multiply that by -1 here. So that'll be 9 minus 5. And then just simplify this. 9 minus 5 is 4. So this is 3 square root of 5 minus 5 divided by 4. And that's your answer for that one. So I want you to try example 6. So remember, you're going to start off by identifying what is the conjugate of the denominator. So the conjugate of 1 plus root 3 is 1 minus root 3. So remember, you're multiplying by the conjugate divided by itself. So 1 minus root 3 over 1 minus root 3. So I have this one set up for you to go ahead and simplify that. So go ahead and try to simplify number 6. Pause the video, give it a try. When you unpause it, I'll have the solution here for you. So hopefully you gave this a try. When you distribute the 5 to the 1 minus square root of 3, you get 5 minus 5 root 3. And then when you FOIL the bottom, so 1 plus root 3 times 1 minus root 3, when you FOIL that, you get 1 minus square root of 3 plus the square root of 3 minus the square root of 9. Those plus square root of 3 and minus square root of 3 makes 0. So I get 5 minus square root of 3 over 1 minus 3. Simplifying that a little further, 1 minus 3 gets you -2. So it's 5 minus square root of 3 divided by -2. This is okay. Math Excel may take this as an answer. The more simplified answer would be the one I have over here to the right. So if I just change the signs of the numerator, then this is a little bit better of a form than that. But either way, I think Math Excel would take both. So you should be able to do the assignment in Math Excel called dividing radicals.